We figured out the work. Now we got to figure out the space. We need to size up the memory. And this is a very physical challenge. How in the world do you fit a digital brain with billions and billions of parameters onto a tiny little silicon chip? So what's eating up all that precious real estate on the chip? Well, it's mainly four things. First, you've got the model parameters themselves. That's the core knowledge of the AI. Second, the gradients. Think of those as the instructions for how to learn. Third, the optimizer states, which kind of help the model remember what it's learned so it can learn more efficiently. And finally, activations, which is just temporary scratchpad data that gets created during all the calculations. So yeah, that's a lot to cram in there. The next logical question is, okay, how can we shrink that memory footprint so we can fit even bigger models? Well, one of the most powerful tricks we have is playing with data precision. The standard is something called float 32. It's super precise, but it takes up 4 bytes for every single number. But for a lot of the work, we can get away with using float 16. It literally cuts memory usage in half, down to just 2 bytes. Now, it's less precise, sure, but it keeps the range of numbers you need for deep learning. It's this crucial trade-off. Do you need perfect pinpoint precision, or do you need to fit a bigger brain? Making that call is key to efficiency. And just like we had a magic number for compute, we have one for memory too. You guessed it, and that number is 16. Let's dig into why. So here's where that magic number 16 comes from. For every single parameter in the model, you need 16 bytes of memory. 4 of those bytes hold the parameter itself in high precision. Another 4 bytes hold its gradient. That's the learning instruction. But the biggest chunk by far, 8 whole bytes, is for something called the atom optimizer. It's super popular and effective because it keeps track of 2 extra numbers for each parameter to help the model learn smarter. But boy, does that memory add up fast.